epsilon greater than 0, there exists a corresponding delta that's greater than or equal to 0 such that f evaluated x comma y deviates from L by no more than epsilon units whenever the distance between, everybody, you know what, I am rushing. I've already made a mistake with my notation. I meant to say the limit of f of x equals, of f of x comma y equals L if, or excuse me, as, jeepers, not that, but as the ordered pair x comma y goes to a comma b. Yes, I know. I'll slow down. Whenever the distance between the x comma y point and the a comma b point is no more than delta units. By the way, it's the limit, so I don't really care what happens if I'm actually there.
So, unlike the test, are you going to have us do delta epsilon proofs of multivariable functions, or are you going to have us just say, hey, take this limit of this stuff and you're done?
No, I wouldn't insult your intelligence. I asked you for some proofs.
Okay, just that.
Are you going to require us to know all these symbols? I mean,
They will make it go faster. If we do know them.
You know, you guys, what does your author write? Does he use these symbols?
probably not. He probably uses English.
Because that kind of looks like alien language scribble.
You totally mystified somebody with that.
You guys told me the first 5 minutes of class. I'm actually surprised you wasn't missing one from the whenever. Sorry, guys, I'm serious. I'm kind of interested if they really show me.
So is this so let's say I didn't study delta epsilon in math 30. Is this exactly the same as what is it, 2.7 I think, but just more?
Oh no, this is so much easier than what you did back in section 2.7.
Okay, because I completely skipped that section. I
God,
don't know any of it.
I think when I teach math 30, I'm so much more sophisticated than I am here. Because when you look at proving the limit of a quadratic expression equals some number as x does something, the proof's going to be more, excuse me, I'm sorry, the proof's going to be more elaborate.
Okay.
So I think the proof's here really simplistic. You'll see. I'll do it again. Can we take some baby steps first, though?
Yes, please.
Oh, by the way, when I'm looking at the book, I have to confess he does not use my universal and existential quantifiers, but everything else is the same.
Did you use your subset?
Oh, sorry. No. Gosh, his arms probably getting tired of writing such that all the time.
Is that supposed to be a delta, or is that supposed to be
That's delta.
that's what we're trying to find. You know, because I wasn't sure. So
Why don't they use the triangles instead of the deltas?
because it's a lowercase.
We tend to use the triangle's uppercase.
So I mean that is a lowercase.
We tend to use the uppercase delta too often in mathematics for small change.
Okay.
I think for that reason, I think it'd be ambiguous if I used it here.
What's the symbol for big change then?
You know, when it comes to the calculus, you're not really interested in big changes. You're only interested in infinitesimally small changes.
Is there any mathematics where you're interested in large changes, or?
Probably.
Sure.
Well, what do you mean by large changes?
I mean, you heard these two.
Who's Napier?
Oh, not yet.
Kepler? I've heard that name.
Joanne Kepler, of course, you recognize from astronomy. But Napier was a mathematician. They worked together, and they got sick and tired of doing things like this. Messing around with coming up with areas of sectors of planetary trajectories. And they got tired of the arithmetic because the numbers were like this. So they decided they'd give up. They'd think of this number this way. And just mess with the exponents. Of course, all the algebra and arithmetic changes, doesn't it, when you mess with the exponents? But at least they're smaller numbers. We call those...
Scientific notation.
Exponential.
Call, think of the exponents. Exponents are
Powers?
logarithms.
Oh.
So I'm being goofy with my answer. Maybe it has nothing to do with big changes, but big numbers. Wow, you didn't even let me finish my word example. So you you guys take a peek at this limit. How about the limit as x comma y goes to, how about the origin?
X comma y goes to the origin.
Well, can you just dive in here and value the limit?
I'm not sure that you
Yeah,
can.
no. Because you have to get rid of that, you have to factor out.
That's a filthy brag.
You have to try to factor it out because.
This looks
if
like it would be
goes
lower.
How do you know I have to factor it out?
It looks like a 0 over 0 form.
Okay, thank you, I agree with that, because the 0 to 0 situation, this is an indeterminate form. So, you and I are gonna panic, just like we did in the past. Panic in an efficient way to somehow clean it up, massage when I take a look at it.
Sorry, one more thing. Is L'Hopital's rule apply here and multivariable space too?
Yes, say that again, I'm sorry.
Can you do L'Hopital's rule?
You don't have to.
Well, I haven't told you how to differentiate function of multivariables yet. Just, you gotta give me another 20 minutes.
Okay.
And I maintain that you and I are gonna panic, algebraically, and massage the beast inside the limit. Piece of cake. I'm so sorry for my phone, you guys.
Oh, that was your phone? It's just beeping noise. I thought I heard it coming from that direction.
Just turn around, okay? And you guys, we can massage. I said, you guys, we can massage.
It's just
Plus y.
X,
x minus y
X minus
The other
y.
one.
X squared
squared
plus
plus xy
plus y squared.
plus y, yeah.
Like, what happened?
Difference of two
We factor a
cubes.
difference of two cubes.
Difference of two cubes. Okay, that doesn't ring a bell. I'm gonna have to go back.
Oh, really?
That's like not deep.
I know.
Actually, I know about math later. Wow, what would you guys have done if you forgot how to factor those cubes?
Cried?
No. No. What would you do if you forgot how to factor those cubes?
Maybe L'Hopital
Formula long
or
division.
something.
It's a piece of cake. You have to confess, when I replace this x with a y, I get 0 upstairs. So the factor theorem says x minus y is a factor of that beast. You simply pull out your nifty little long division bar, put in the dividend's position of the numerator, put in the divisor's position in denominator, piece of cake, and you play the traditional game of, where's my red pen? Play the traditional game of asking yourself the question, leading term of the divisor's position goes to the leading term of the dividend's position how many times? X squared times. X squared times the entire divisor gives me this product. Subtracting the second from the first, that gives you a positive x squared y. Let's play the game again. The leading circle term of the divisor goes to the leading term, what the heck is left over, how many times? X, y times, paying the consequence of my actions. X times the entire divisor gives you this product.
Shouldn't that be an x cubed down there? That you're subtracting from x
My
cubed?
apologies, x squared times the entire divisor did give me an x cubed
Yeah.
minus x squared y. I just somehow wrote it as a 2. That's how it disappeared. And I think subtracting the second from the first, that gives me a positive xy squared. Can I drop down the last term? Now when I look at what I multiply this piece by to get the leading term down here, what's left over, I think it's just going to be a y squared. Y squared times the entire divisor gives me the same darn thing. Ah, shoot, I guess I'm done. The remainder is 0, which means that's the corresponding factor. So you don't have to remember at this stage of your mathematical career how to factor things like that. Just rederive it.
And then how do you get the x minus y? Or my dear?
The x minus.
Minus y on the outside.
I think that's for free because I recognize that when I tried to value this limit directly, when I plugged 0 for x, 0 for y, I got a 0 upstairs and downstairs. So I kind of glanced upstairs and recognized that both these value the same thing, so there must be a factor of x minus y in the numerator's position. In fact, you relax. Putting y in for x, my numerator really is equal to 0. That means x minus y is a factor.
You're gonna have to when you draw the boundary points of this on the graph, isn't like the 0, 0, 0 gonna have to be like a dashed line?
Yeah, I agree with that. And so that's why I have to massage this algebraically first. And now with my cancellation, shoot, you guys, life's a piece of cake. This is just a limit, whoops, in red. It wants to yell. This is merely the limit of x squared plus xy plus y squared. But that simply guides to what?
Zero.
Everybody there? Come on, you guys, everybody there?
Yeah.
No.
Yeah.
No, I think it's horribly wrong. If ever you wrote this on a test, ooh, I'd be so upset. Because,
You didn't say what you're doing.
yeah, I agree. Besides, I'm 100% wrong. Look, this algebraic expression isn't equal to 0. And this algebraic expression isn't equal to its limit. So what's missing?
Your limit notation.
Isn't that important to put in the LAM notation? So I meant to say the limit as x comma y goes to the origin in the xy coordinate.
But if you're feeling lazy, don't like writing the bottom part of the limit, but you know, like from that first part, like instead of saying x comma y goes blah blah blah, you just like scribble.
Yes, could you just draw an arrow? Draw an arrow
I do
down or
sometimes
something
not
like that?
Well, let's put it this way, that would depend on my mood.
Okay.
What if I'm in a bad mood? You would never know that.
When I took Debbie's class for 31, she consistently marked me off for not putting an in-between step between those two. Where
Between
I-
these two?
No, between the limit and the zero part. Where you'd take away the limit and then have the x and draw an arrow through the x and put goes to 0, put an arrow through the center part and put goes to 0, and put an arrow through the y and put goes to 0. Are you going to do that redundant
Isn't it
step?
nice how professors are people too? We're all different.
Yeah.
I'm
Well, I
happy
don't know
with
if Debbie's a person, but there are strong feelings about that.
Well,
class.
I'll put a tape recorder in this room, walk out for a few minutes, see what you say about me.
Yeah, it's all being recorded right now.
You guys okay so far? Yes.
Question about the long division. Can we do that with an equation in 3 variables? Would it be the same process?
What about n variables?
It will, but I have to confess, it's only going to be this pretty if in the 3 variables or 2 variables, if you end up having a factor, if you know what the factor is. And I didn't say this out loud, but notice how you guys, I kind of slid the y cubed over, because I knew it was going to have a couple terms missing. And you had to play a similar game as an expression in 3 variables. You just might not know how many terms it is. But same idea.
So for that, you have to put like x cubed and then like plus like.
Well, as a mathematician, I do know that the next term really would involve 1 less power for x and 1 more power for y than 0 power over here. And then again, decrease the power for x, increase the power for y.
Okay.
Oh, sorry, 0 in front of it, thank you.
And then you repeat the whole thing.
Yeah, I'll talk about that a lot more in math 15?
Which one's that one again? Is that the one we all signed up for?
Yeah.
That one?
Yeah. So you guys, my examples are too
Easy.
easy. Can I say this? Can I not give you any examples where you just plug the number in and you get some number? That would be insulting, right? Okay.
Oh. Nice.
You guys, I don't want to waste time in class today. So come let's look at examples. What if I look? I made some examples up. How about something like x minus y over x plus 1? Can somebody give me a free, convenient, easy way to show that a limit does not exist in math theory?
So if you have like a line that's going like this along an asymptote,
Very nice. Or maybe it doesn't even have to be an asymptote. What if I had just a simple point of discontinuity?
discontinuity, yes, there's
Or
that.
some value vector. I wish I had
Something like that, yeah.
You can just show your function's not continuous at that value of x just by looking at the two one-sided limits, show they don't exist. Piece of cake. This isn't a piece of cake. Because I'm not looking at a number line, I'm looking at the xy coordinate plane. And if here's the xy coordinate plane, and here's the origin, I want to show the limit exists, or maybe show it does not exist in this example. It's got to be the case that I got to talk about coming into the origin from various different paths. And I confess there's infinitely many paths you can come into the origin with. So here, if you want to show a limit does not exist, the game to play is to show two paths for which the evaluation of that limit would be a different number. So let me show you with this example what I mean. Do you guys agree then as x comma y goes to the origin along the y-axis, then this limit basically becomes this limit. Let's see, limit of, as x comma y goes to the origin? Oh, I don't mean that. I mean x comma y is going to the origin, but y along the y-axis, in which case x is always going to be 0. So I think I'm just simply valuing this limit. But jeepers, that's just going to give me a negative y over y. But that merely simplifies to limit as 0 comma y goes to the origin of a negative 1. Oh shoot, piece of cake. Maybe not. Should be a piece of cake, but I can't do my arithmetic. It should be negative 1. However, if I came into the origin along a different curve, have it more simplistically the x-axis, then I think along the x-axis, I think this limit becomes this limit. Just simply the ratio of x to itself. But that's merely the limit of my positive 1. And I think that immediately amounts to positive 1. And because along these two lines, the limit evaluates to two different numbers, then the limit does not exist. So you guys, to get into play is a little bit different than math theory, I suppose, in that sense.
So, how would we go about showing that some limit does exist?
Like in my last example. If you get a 0-0 situation, try to massage it algebraically.
And you can't do that, then
Yeah, and if you can't do that, maybe you could try to see if the limit might not exist by coming into the origin, or coming into the a comma b, whatever that point is.
well, but if you have
That's a sign.
infinite possibilities, you have to look at every possibility.
Yeah, there's infinitely many possibilities. I hate to say you have to look at every possibility. You got a hunch that the limit doesn't exist. You can try a couple paths.
Well, yeah, I'm just saying, this isn't sufficient.
You should expect me to ask you this question. Show me that the limit does not exist, so you don't mess around. And I think if you can answer the question kind of asking directly, that would illustrate that you really understand limits. Linda?
So you're allowed to plug in one of your values and evaluate the limit separately?
Absolutely, think about it. I
Okay.
think along the y-axis, if I come into the origin, I'm still coming into the origin. It is one path. It might be a simple one, but it is a path coming into the origin in 2 space. Perfectly legal.
So it's that easy, you just plug in B for, A for X, and then evaluate that limit. And
Oh
then,
yeah, I mean, all the math is easy once you see what's going on.
And then B for Y and that. Okay.
Oh, you guys, let me elevate the level of complexity. How about number
Well,
3?
Actually, I have a question with
Yes.
that. So, it's kind of a silly question, but we never did this in Math 31 or 30, but is there any way of proving that a limit does not exist using delta epsilon proofs?
It's not that, how do I answer that question? So I never came with an example like that in math theory.
No, no.
I think there's a way you can illustrate
Okay.
that for a given epsilon does not exist a corresponding delta. And I suppose you can consider it your proof.
Huh.
I just think in those cases it'd be easier just to look at the one-sided limits.
Okay.
Because invariably that's what's going to happen.
Huh. So, like, how would that look if you did it with like a delta epsilon proof?
the limit evaluates to two different points,
Say it again in a full sentence.
because along these two lines, the limit evaluates to two different points, is that what it was?
Oh, you mean that I raised?
Yeah.
My apologies, that's exactly what I said. Because along these two lines, the limit evaluates to a different quantity, then the original limit does not exist. I just have to show that in two paths coming to the origin, that I get different evaluations.
Okay.
So you guys take a peek at this example. X-axis, Y-axis, if you're deep, deep REM sleep, you know what it looks like. Clearly, according to the picture, the limit right here does not exist, or at least its x approaches 0. So using epsilon delta notions, I could say this. Let's suppose that the limit of f of x, as x does this thing, is equal to now. Actually, let's suppose it's equal to, how about just 0 itself? And if I think the limit's going to be equal to 0, then notice if I deviate from 0 by epsilon units where epsilon is equal to a half, then I've got this horizontal band. I could just, in words, talk about there'd be no corresponding delta about x equals 0, for which the corresponding y values are within one half unit of 0.
So you just show it with a picture.
Well, I can use the words,
Or an
to
illustration.
describe it in terms of words and
Okay.
mathematical symbols. But writing down exactly what I'm just saying.
Okay.
Let's suppose the limit does exist. Let's suppose it's equal to this. Then certainly if I deviate from 0 on the y-axis by 1/2 unit, up or down, which means delta, or my epsilon is equal to 1/2, there would be no corresponding delta about x equals 0, for which the corresponding y values over the integral are within 1/2 unit of 0.
Okay.
Logic.
Yeah, yeah.
But messy and kind of.
So you're getting,
Wouldn't that necessarily require continuity, at least around the point that you're trying to find?
You know what? I do have continuity on either side.
I know, but bridging that point is what I mean.
Well, if my curve looked like this, here's my A. Here's my L. I'm certainly discontinuous at x equals A. That is an A. But the limit still exists. Bless you. So remember, when it comes to limits, even in higher dimensions, I don't really care what the heck happens at x equals A, or in my case, at the point A, comma B. It's completely irrelevant.
But what about a completely discontinuous function?
What do you mean completely discontinuous?
There's no continuity to the function whatsoever.
No either function?
That is my statement. That's not.
The limit does not exist.
It depends. That's a much more complex question. Because now you're asking me to come up with an example where I'm discontinuous at every single value of x.
Well, that's more what I was confused on. It just, that was a good.
Is that possible? Oh, yes.
You could actually find
For
something
f of x
like
is
that,
equal to nothing.
Yeah.
Ooh.
Defined.
Defined.
On,
Oh, defined over.
defined over 0 to 1.
what am I trying to figure out?
That's part of the math question, right? The math fun.
You're not smart enough to read it.
Zero does not.
That would work.
X is not an element of Q. What's Q?
Q is just a rational numbers. Isn't that the letter you use for rationals?
0 if
We use R for rationals.
Oh, no, we use R for reals.
For reals, oh, we use Q for rationals.
Oh, I see
That's
what
what
this means.
I'm
So basically,
Okay.
it's just the two cases. If x is a rational number, then it's gonna equal that, and that's gonna come out to 0, and it's gonna be 0 if x is not. Oh,
So there you got discontinuity at every single value of x. Somebody asked. That's good.
Is it differential? Oh, I'm sorry, is that, can you take one of that, you said? Is that a question?
no. Do not take
That's more complex. That's more
Wait,
complex.
seriously?
It just wouldn't.
You guys, what about this function? Let's show, and again, you guys, I don't have to make this up out of thin air like I usually do. How about 4x squared y? So 4x squared y over x cubed plus y cubed. Do you guys agree here too, I've got a situation in which I have an indeterminate form. I get a 0 to 0 situation again. So if you guys don't mind, allow me, can I just use my hands? If I were to just simply come in the x-axis, that means y is going to be equal to 0. And if y is equal to 0, what's this fraction? So the limit goes to 0 since I'm always there. But along the other axis, if x is equal to 0, then this fraction becomes,
0.
It becomes 0 over
It's still
y
0.
cubed.
but that just becomes,
0.
oh shoot, that's not two different paths, is it? I got an idea. Let's do this instead. Let's see what happens as x comma y goes to the origin along, how about any line?
Okay, slow down for a second.
Yes, I will.
Can we just erase the little, makes it longer?
It makes it what, Linda?
Well, then you just change the problem, but I still have to write all the other stuff.
I'm sorry. Then I think I get the following. The limit of my 4x squared y over x cubed plus y cubed, excuse me, as x comma y goes to x comma mx, is merely the limit
Wouldn't it be mx plus a constant, or,
say it one more time.
wouldn't, in your limit statement down there, as x, comma y approaches x comma mx, wouldn't it be written as
My
x-
apologies.
mx plus a
I'm not
constant?
paying attention. That is horrible. I meant to say x comma mx goes to the origin. I'm not going to change my destination from the previous example. I'm still going to the origin, just like my apologies.
So this is another example.
It is another example.
Okay.
So on example number 4, I changed the number.
I'm confused.
No,
With what?
wait, or is this 4 and 5 right now? I'm confused.
4 and 5? What do you mean?
We did it different
No, but you, okay, but now you're changing it along y equals mx, is that different than just x, y approaching the origin?
No. No, I'm saying,
It's all one.
I want x comma y still go to the origin, choose space. I'll draw a picture. Here's the x-axis. Here's the y-axis. Do you remember how in my last example I said this? Oh, when I came into the origin along the x-axis, I got one value from my limit. But when I came into the origin along the y-axis, I got a completely different value. In this example, I tried it without me writing. I tried to come to the origin along the x and y-axis, but I got the same thing. It's now I'm just simply saying, what if I come into the origin along some other line? How about the line y equals mx? Just you see what happens.
Was the limit 0 for both of them?
Yes, it was.
Okay.
It was 0. And I simply maintain that if I do that, then I get this mess right here. Is that going to be a 4m x cubed? Done all over x cubed plus, oh, an mx cubed. Oh, easier.
He substituted.
So Linda, you're saying I change the problem again?
Well, now, you first did it this 4x squared y over, you did it with that function as xy approached 0, 0.
Yes.
Now you're saying we're changing it xy approaches 0 as long y equals mx. Oh, you're saying, so instead of,
I'm saying, Linda, check this out.
instead of an axis, a random line
Yes,
space.
that's why I drew this picture. Now let's see what
Okay.
happens as I come into the origin along some other line besides just the axes.
Okay, now I get it.
Linda, I'm asking you to show me that it does not exist. I'm tired, I'm lazy. I think the easiest way to do that is to show that the limit comes to a different value along the x and y axes. It's just, it didn't happen. So I gotta find some other path to come in. And check out what happens. I maintain, if I can keep my arithmetic straight, that this is nothing more than the following limit as x comma y goes into the origin. Egads, you guys, look, algebraically, can I pull up the x cubes?
Yes.
They cancel.
Yep.
And I think I'm merely left with 4m over, is it a 1 plus m cubed?
And we know that m is just a constant, right?
M is just a constant, it's a slope line which I'm coming in on.
So you can keep our notation as x, mx for the limit, or is it okay if we just?
You know what, I didn't write it that way, no, it really doesn't matter, because I'm stating that I'm coming along the line, I think it looks nice if you do put in MX, but it
So-
doesn't make a difference.
Don't you have to say, m cannot equal 0? So.
You can have a flat line.
You go on.
You can have a flat line coming in.
I've already looked at the case when y is equal to 0, because I checked out the limit when I came in along the x-axis.
So now you can just plug into different values.
So you can like plug in 1 to.
Yes, that is
the other.
exactly what they did.
And
So we're,
Should what be an MX?
So y,
oh, so that's why we're cute.
the limit, second limit, as x, y goes to the origin.
The notation on the bottom, where it's x comma y.
What about it?
The one in the left, x, y, shouldn't it be x and x?
That's what you're just discussing, I'm saying it doesn't matter, it doesn't make a difference. I can get away with not writing MX only because I stated I'm coming along the line. And like I was telling Alex, I think it looks nicer if you do it your way. Like I've been consistent with my previous example. I think it looks nicer if you place it in MX, but it doesn't make any difference because I'm identifying the path.
Okay, sorry.
That's quite right, man.
So m can be any number except for 0. That's what.
I disagree, I think M could be 0 as well.
But if m is 0, then it's going to be. It's going to not converge, but it's going to be equal to 0.
And that's just fine, so the limit is equal to 0 when I come along the path, which is the
One
x-axis.
distance.
Oh, that's one.
There's nothing wrong with that.
Now, where you wound up on the right-hand side of your limit,
Yes.
as x comma y goes to 0 comma 0 of 4m over 1 plus m cubed, wouldn't that limit evaluate to the same thing for any? Well, it would be entirely dependent on m, right?
Thank you, you've answered the question. In evaluating this limit, I get an expression that depends on M. So clearly, this evaluates to a number dependent on what M is. For example, if M is equal to 1, what does this limit value to?
4 over 2.
4 over 2, which is positive 2. Oh shoot, we're done. Since the limit came to 2, as I came along the other path, when m is equal to 1, it differs from the limit as x comma y goes to the origin along the x or y axes, and therefore the limit does not exist. Just like in my last example, I just think this one's a bit more sophisticated because it wasn't merely just coming in along the x or y axes.
And M is the slope of the line.
Yeah, because I stipulated that I'm coming on this line where m is understood to be a slope.
So-
I'm still trying to.
Matthew.
I'm still trying to visualize this. So
Yeah.
you.
To visualize, do
Close to
this, x-axis, y-axis. I want to come into the origin along, how about this blue line right here? Whose equation, by the way, is this? Then what does the limit of value to? Well, actually, it values to this. So if m is equal to 1, I guess the limit of value is to positive 2. But if m is equal to 0, the limit of value is to 0 itself. I just found two paths for which I get a different limiting value. Therefore, this limit in terms of x and y simply does not exist.
So
Okay.
you would only do something like this in situations where you know you don't have continuity at that point, right?
Oh, you know what, Brad, you're right, and guys,
Okay.
maybe I should have said that. I mean, immediately when you look at a limit, what's the first thing you guys do?
You check for continuity.
Yeah, try it out, try to evaluate it. It's just immediately when you plug 0 in for x and y, you get a 0 to 0 situation. That screams out at me that I've got issues
Okay.
with the limit. But this question's a little bit hokey. I'm the one telling you that it does not exist.
Okay.
And so you know to come in different paths.
So this is really more of a proof than a question.
Okay, I mean, it's not a formal proof in terms of epsilon deltas, but yeah, I guess so.
And when we do know how to derive with two variables, we can do the L'Hopital's in the free space. Like,
L'Hopital's doesn't make any sense right now because I don't know how to differentiate a function in more than one
well, I'm
variable.
saying, but once we can, would that be something we want to do in this situation?
Is L'Hopital ever applied to something that's got more than one variable?
Well,
Is that
no,
just
because
because
more
we're not there
complex
yet?
since I've got so many different directions to come in on.
So it wouldn't be it wouldn't be the choice here, even if we didn't want to do
Correct.
it.
Is there a version?
You guys, that's such a good question. Can we stop for a minute? I guess we could do this. To try to use L'Hopital's rule, if I could talk about differentiating with respect to only x or respect to only y, which by the way, I'll call it partial differentiation, maybe even today. That's what I expected. That's going to be a problem. Because that means I'm coming to the origin, or whatever the point is, only along those axes. What about coming in from other directions? so I think even talking about those, if I can call them this, partial derivatives is not good enough. I need to talk about a multi-directional derivative, and I can't do that right now. I gotta start talking about gradient vectors and look at more sophisticated vectors this semester to be able to do that. And it'll be much more problematic.
What would the,
So,
sorry, never mind.
you're talking about, we're gonna have a situation where we're only looking along the axes?
No, I'm saying with the new differentiation process you haven't seen yet, partial differentiation, is too limited to use L'Hopital's rule because I'm only coming in from the x and y axis. I'd have to talk about a whole new differentiation process coming in from any direction. And we will. We need to worry about it. I mean, you guys need to worry this semester about this. I'm at the top of the hill, and I just kicked my bucket, which is full of water. How's the water gonna go down the mountain, or the hill?
It's gonna take the path of least resistance,
It's gonna take the path of least resistance. How about the path of greatest descent?
the highest gravitational.
But as the water's flowing down the hill, the path of greatest descent depends on where I am, because it keeps changing. And so we need a way of describing that changing direction, and we will. It's called the gradient vector. Not later, not next semester, I'm talking about this semester. Okay. You guys, I lost where I'm at.
You're,
So we've answered the question, haven't we?
We just showed that, that limit does not exist by evaluating it coming in on a bunch of different lines.
Linda, you're not gonna yell at me, are you?
What's that?
You're not gonna yell at me, are you?
Probably.
Yeah.
I have one more,
Yeah.
like, is there a gradient integral?
Is there what?
Is there a gradient integral?
What's that?
Ooh, jeepers. Sometimes when I integrate, life's too difficult, and I replace it with a different kind of integral involving that gradient vector.
Okay.
That would be another 8 weeks.
Are those called line integrals or something else?
Divergence theorem, Green's theorem, Stokes' theorem. All three of them are just different variations on the fundamental theorem of calculus,
Okay.
just in higher dimensions. You guys, how about another complex? Oh, jeepers.
Yeah, I was gonna say, we
Oy,
need to
oy,
give
oy.
us that quiz.
How about x squared y? And x squared plus y squared.
Why do we want to miss the quiz?
Oh, you got Eric with the quiz today? I probably won't grade it this weekend. So, I expect you all to get 10s anyways. It's that easy. Don't worry about the quiz.
Only on the inside, alligator. Yeah, on the inside.
You guys, can I try not to write? So let's talk about this pattern. No, let's not. Let's talk about x-axis first. Coming to the origin on the x-axis, y is 0. When you plug 0 in for y, what do you get? 0, so the limit of values is 0. If I come in along the y-axis, when x is equal to 0, don't I get the same darn thing? So can I talk that fast? And I think that if I come in along a line like y equals mx, I replace this y with mx. Well, I've got 3 x's upstairs but 4 downstairs.
The degree of the denominator is higher than the degree of the numerator.
And so what do you think is going to happen?
They don't go to zero.
I'm doing this, I'm panicking. I'm trying to find different paths going to the origin for which the limit of values is something different. That's what I'm trying to do.
Yeah, I'm hearing what you're saying, but you're gonna get, oh no, you get x cubed over x squared, okay.
what if we let y equals x squared?
Ooh, that sounds slick. Let's give it a shot.
What?
He said, let's see what happens when y is equal to x squared.
Now, how is that different from coming on various lines? Are we
Oh,
talking about?
it's hugely different. Watch. Here's the x-axis. Here's the y-axis. I maintain, so far, coming on these basic lines here, and maybe